we interrupt this musical mathematical video to bring you some examples of Gaussian elimination. If Gaussian elimination is a method of elimination that makes any system solvable by substitution, then that means that it must make this system, what is called a 3x3, 3 variables and 3 equations, look like this. There's still 3 variables and 3 equations, but you can tell that it is simpler and it is in the form that you already know how to solve. So Gaussian elimination allows us to eliminate variables in order to look like the second system of equations, and we can solve it easily. So your teacher is about to pause the video. Take a few seconds to look at this system. What do you notice and what do you wonder? Now let's think about this. We want to start here with this system of equations and use our skills to get here to this system of equations so that we can solve easily. What do you notice about the equations, and what steps do you think occurred to get to this point? So let's get started with Gaussian elimination. When using Gaussian elimination, you need to consider two processes: what you write and what you think. There are things that you think that you do not necessarily need to write on your paper. We start by writing the system. Always write your problems, right? Then we're going to think about this. I need to get rid of the x terms in both the second and third equations. To do that, I must use the first equation to eliminate those terms. Let's start with just getting rid of the x in the second equation. If I look at these and say row 1 and row 2, then 2x and negative 2x automatically eliminate. So I can just add row 1 and row 2 and rewrite that in row 2. This is what I meant by what you think about and what you write may not be the same thing. So you think about adding those two equations together. Give you just a second to write it down. And then 2y plus z equals 7. Now then what you write is that equation in place of the second equation. It just moves right over in place of that because you've done the elimination. Now we're going to start with that. What you see on your paper is this equation. Now you've got to think about what you want to have happen. You want the 2x to help you eliminate the 4x. You have to use the first equation to eliminate the term with the x in the third equation. So I would need to multiply the first equation by a negative 2. That would give me the negative 4 that would cancel out. But remember, the negative 2 has to distribute all the way through that top equation. So on the side, you are writing down negative 4x minus 6y plus 2z equals 12. The negative 2 times your row 1 plus then your row 3 written underneath it. And that's going to give you 3z equals 15. Now then you're going to put that in place of your row 3. Notice your row 1 is not written as negative 4x minus 6y plus 2z equals 12. It is your original row 1. That's why I said there's a difference between what you're thinking about and what you're actually writing on your paper. That first equation does not change. The second one, you rewrote it, and now then your third one is put in there as your 3z equals 15. And so here is what you see on your paper. Notice that row 1 leads with the x term, row 2 leads with the y term, row 3 leads with the z term. So now you're ready to think, oh, no struggle, I know how to solve from here. Pause this video and let me solve. Okay, let's try one more. They can get a little tougher. This one will have one extra step, but it's not bad. You can handle it. Example 2. Let's write this system. X minus y minus 5z equals 6. 3x plus 2y plus z equals negative 1. Negative x minus 4y minus 10z equals 14. Now let's pause the video and try to eliminate the terms with x. When we come back, we'll see how well you did. Okay, so hopefully, and I know this is just your second one and it takes a little bit of time on these, but hopefully you could remember to stop and think and move over here. Okay, I have to use the first equation. If I want to get rid of x's, I'm always using that first equation to eliminate the terms with x's in the second and third equations. So for my second equation, it has a 3x as the leading term. So I want to multiply the first equation by negative 3 so that my x's will be eliminated. But remember, the negative 3 distributes all the way through. So your equation looks like negative 3x plus 3y plus 15z equals negative 18. Your second equation remains the same, 3x plus 2y plus z equals negative 1. And when you add those, you get 5y plus 16z equals negative 19. And remember, when you go back and write this on your paper, the first equation does not change. You still write down x minus y minus 5z equals 6. You just changed it in your mind to help you get that new second equation. Now let's move to the third equation. This is what you see on your paper, and in your mind you're thinking, okay, I have to get rid of the negative x at the beginning of row 3, and I have to use row 1 to do that. Okay, must use that first equation. So that's a pretty easy one. The third equation is r1 plus r3, and it's going to give you your new third row. So you just write the two of them down and add together. You get negative 5y minus 15z equals 20. And now then you rewrite over here. So your first equation, just like it looked in the original problem, the second one that we came up with from the previous slide, and then this one. Oh, but we're not in x, y, and z leading form. My second and third equations both have y's at the beginning. That's the little bit of difference on this one. So let's work on that. So on your paper, you see these three equations. This one is a little bit different. I don't need to use the first equation to work on the third row and get rid of that y. My x is already there by itself, so I need to move to the second row. If I want to eliminate y's, then I'm going to use the second row to help me get the third row to where the y is gone. So I've got to think about it. One more step. Eliminate the term with the y in the third equation. Use the second equation to eliminate it. So that would mean on this one, since I have positive 5y and negative 5y at the beginning of the second and third equations, I just want to add them. That's going to give me z equals 1. So there are my new equations, the first one, the second one, and the third one. The z equals 1 is now in place. It's the new third equation, and you can tell you are in the right form to be able to solve. So now you know where you are and you know what to do. You're ready to solve again. If you have time, here's one more equation. Pause the video and see if you can figure out what to do. If not, just remember,